So I've not actually got that much to talk about today, for once. Um, but what I wanted to do was to maybe switch this over to my monitor, and you could just see what it's like for me browsing the internet, because everybody has their own world that they exist within online, and we very rarely get to see inside somebody else's world and like what they see. I like to think that I structured the way that I see things online in a way where the best information comes to me in like the right, in well, I guess like in a way that like allows me actionable data. So maybe seeing that for yourself, I don't know, you might learn a thing or two, or maybe I'll learn a thing or two as well. So most of the time when I start a browser, I will end up on this subreddit. Absolutely one of my favourite subreddits. Me and a friend of mine used to watch this to no end. So it's all about like people that have mastered a craft and they're either competing, or there's like how things were done in an ancient world. I don't know, I just like making things. Like it's this is why I'm into like Fab Labs and 3D printing and all this kind of thing. So it's just, I don't know, tactile, right? It's like I like making things with my hands, which is why the world that we live in right now, it is a little bit of a shame that people have moved away from that. I was literally only speaking to a friend of mine before about how just like people don't really treat skills like hand skills, tool skills, like all that kind of thing. The things that like literally make like the nuts and bolts, quite literally, of a country. And yeah, there's just no respect for it anymore. And like we live in a service economy now. Like everything's online. Code can do anything, and even though that's really not the case. Like when it comes to like physical things. I mean, yes, 3D printers have come a long way. Like I mean, I've 3D printed this little small Bulbasaur a long time ago and painted it, and also printed this little guy. So this is a little planter that I made. It's like a little Bulbasaur planter, but I don't know if you can see on the bottom there. I think it's faded now. But basically, I embedded an NFC chip inside of it, so when you scan it with your phone, it actually comes up with a model of the Bulbasaur itself. Like I mean, considering we're moving into a metaverse kind of world where like digital and physical are paired like that, it would just be nice like to be able to just scan things and be like, oh, okay, now I have like an accurate dimensional model of this object that I have picked up. But yeah, I don't know, I do a lot of 3D printing. Quite like 3D printing. I'm in the middle of building a SpaceX helmet at the minute, which is downstairs, like being sanded in the garage. And see, the downsides of 3D printing are that when you have errors in the print, like it's very difficult to fix. And you need to use like quite a lot of filler and like sand it and paint it and all this kind of thing. So there's like a lot of additional work that needs to go into most 3D printed things, and I think anybody on YouTube that does 3D printing will attest to the amount of work that goes on behind the scenes, like just getting good prints in the first place and all that kind of thing. But yeah, like I mean, so that's it. I've got a bunch of open loops at the minute. Like I've been building these little meta magnets. Actually, I don't think I've shown people this before. So, what these are are individual like metamagnets. So you can see neodymium magnets inside of there, arranged in the shape of a star. So anybody that's played Dungeons and Dragons before will know about a D20, right? So a D20 is an icosahedron, and it has 20 sides. So basically it's looking like that, so that's why I put this little guy in the middle there. This is a positively polarized metamagnet. This is a negatively polarized metamagnet. I hope. I still haven't checked it against any positive or negative magnets, so I might just be getting them completely the wrong way. You see, this guy, though, is a metamagnet I made out of two positive halves. So it's glued together, like, and there's tension in there. Like, it was like I had to hold it in place while the glue was setting. So there's like a positive, I guess like a negative entrapment field here. And I guess if you did it with the other one, like you would get a positive entrapment field. My reasoning for that is because I have, where is it? I think it'd be quite good to go through what I've been working on. I don't know if you can see what this is in here, but this is a tritium vial. So what it is some radioactive hydrogen that I just keep in my drawer. I should probably wrap it in lead, to be honest, just to make sure it's like completely radioactively safe. But the prevailing theory in fusion is that like deuterium tritium fusion is like the way to get things to fuse, right? Not entirely sure about that, but yeah, I'm just testing that out with like these different magnets and what kind of like effects I'm getting like in different scenarios, like without putting any electricity into it. I'm just trying to grok like, are there any like anomalous behaviors that are coming out and all this kind of thing. There are a couple actually, not with the tritium, but with the actual magnetic field. Now I can do with another one of these magnets. Bear with me while I get one out. You just buy these magnets like electronics suppliers. There we go. So they come like this, little tiny magnets. But yeah, so especially in a field like this, so you would think, because all of these are pointing inwards right now, and I drop that in there, aligned with the field, and it's actually being pulled in. So it gets pulled in and flipped upside down, so you can see the way it sits there. I think this isn't entirely aligned properly, like there is a way of getting it so it just kind of sits like in this hole at the bottom. So it's like a sprung thing. I've got other videos of it, so I might just like clip one in here. But there's a fusion researcher called what's his name? David Primer, and what he did is take the shape of a field that he wanted, which was like a bowl shape, and actually get magnets sintered in that shape. So he has the bowl magnets that are like his proprietary thing and all this kind of thing that emulate this kind of like artificial monopole. It's like a metamagnet out of like sensitive parts, right? And he was getting this kind of flip ring. Like I'm not entirely unconvinced that he might have achieved fusion already. Like there is like when you go and watch his videos, like there's a plasma ring that forms inside of the bottom of the bowl. It's like this flip ring. But it actually leaves a scale on the bowl magnet from his plasma experiments. And I think if you were to check, I think you'd find additional elements in that scale, which would mean that he's already achieved what he said he's going to achieve. Like, he's gone the other way now. So, like, originally the magnetic orientation for these was to have them kind of sat like this. So you kind of have two bowls, and that kind of emulates the double torus structure of galaxies, supernova explosions, like all kinds of stuff. And the basis behind this is that because you get in like high energy stars and like after supernova, like neutron stars and quasars and all this kind of thing, there are normally like jets of high energy particles that are like coming out of the poles. And I mean, like, this isn't even related to just stars. Like, we get auroras on Earth, and like you've seen in Jupiter as well. And the prevailing theory right now is that these particles come through like build up plasma on the magnetic field, and then it kind of shorting down the poles. Now I wonder whether there's some particles as well coming up as well, and that's what causes the interference pattern. So yeah, like my theory is that if you emulate, take these ball magnets and kind of like make them different enough that like they fall outside of patent as well. This is actually just a geometric magnet, so it actually comes in two parts, and it is a D20. So that's like completely solid there. But with a bunch of magnets in the middle now, I need to glue all this down. But yeah, so I bought this little plasma globe. It's like literally the best thing. Right, how do I do this? Try not to touch the bottom of it, because there is currently high voltage touch point, like exposed. So I'll turn this on upside down. Hold it like that. There you go. So you can see you have plasma. It kind of follows people's finger, but you can kind of see how the magnetic field affects it. I don't know whether you're able to see that, but I can see it. It kind of forms an aurora around the entry hole of the what do I call it? Like a negative ion trap or something like that, I don't know. Let's turn that off, get that unplugged, keep everything safe. But yeah, so I started to, after this, like I kind of was in with tritium and all this kind of thing, and trying to work out like what I could do before like doubling back. So I mean, if I'm one thing that I'm grateful for that Elon has like brought into the public consciousness a bit more, is that like you go back to first principles, and like that's kind of where I'm going right now, is that like back to my university studies and like how that whole fusion reaction works and the different energies that come out of it, but also like going back through the research for fusion, just in case anybody's missed anything. And basically there was a really anomalous graph that I can probably put on screen actually, that shows the cross-section, right, of all the different fusion reactions. And there's this really like anomalous spike in the proton-boron reaction that like goes up and like sits exactly level with the deuterium-deuterium reaction. Now, I've always liked deuterium because it's neat, it's like kind of two-dimensional, and so how do I explain this? There's like a geometric construct, right? The simplest 2D shape you can make, right, is a triangle, and all you need for that are 2 points and an angle, because you can infer the rest out of it. Now basically the way that it works in 3D is it's 3 points at an angle, so you have these tetrahedrons that are the absolute simplex geometric shape. And one thing I like about, well, if you look at helium-4, right, the only shape it can take in the atom is tetrahedral. It explains why helium is so unreactive, because it is like an absolute simplex shape, right? It's very difficult to come at that in a way that can react with it. Same applies with carbon-12, right? So carbon-12 is a cube octahedron. Hold up, cube octahedron. Yeah, it's a cube octahedron shape. Because basically a cube octahedron is defined by wait, this isn't right. That's a different one. So yeah, it has 12 identical vertices, right? And the basis for this is that, I mean, Buckminster Fuller, he defined like this simplex shape, having like 12 equally spaced vertices, and when you look at elements that the entirety of chemistry is based on, it's carbon-12. Because it has like the most stable mass, it's like very, very consistent. So you have two pieces of evidence there. You have helium being one shape, carbon being another, right? So how do you make carbon? Boron plus a proton. And how do you make helium-4 is 2 deuteriums fusing. So I don't know, like just there's something about it that it makes sense, it's beautiful, and like it's backed by evidence. So this is where it gets exciting, right? So like if you can work out a way to get these particles to come together so they knit, right? This is like anything to do with enzymes, right? In biology, right? You need the right keying for things to go together, and the same applies in particle physics. Right, so like what the order of reaction is though, right? So like you can use maybe boron electrodes in a hydrogen environment, pass a current through free space, and maybe get hydrogen to fuse into deuterium, and also get ionic hydrogen, which is just a proton as well. So like if you can pump enough energy into that, it'll be such a hot plasma between those 2 points that I see. Oh, right. Oh my god. So, yeah, if you use like a boron electrode with a hole in it, and use that to like discharge across some gap with, I don't know, like I guess the length of it would be important as well. Like if you can get like a standing wave between there, you're effectively creating an atom trap. But you shine laser light through the hole in the boron electrode, right? So this kind of, if it's polarized, you'll get like a spinning aurora coming off the boron tip, right? It's got like a hole in it. And same with the other one, you can polarize it, you can do whatever you want with it to get the different waveforms inside the plasma. But then by shining laser light, you're entraining the space that the discharge is happening over, right? And there's been evidence that you can, if you need to tune the laser light with the discharge, right? But you can effectively get the discharge at the kind of lightning bolt that kind of comes off the end of it to actually like entrain and follow a straight line. If you're like pre-doping a certain volume of space with laser light, so there's, and it's like, I guess there's more energy in that space, so you're creating a discharge path. I honestly think you can just do this in water. Like, I think it's just that we are so dumb about the way we're going about this, like having rarefied hydrogen environments when like the pressures and temperatures in the center of the star are like orders of magnitude. Like, sure, you'll get some fusion inside of a vacuum reactor, right? But like, what if you could just do it in water? And then you've also got like radiation shielding around the reaction as well. Like, there's something about it that just makes sense. I guess like you would be struggling a lot with the pressure coming back in on the plasma, but that's only a matter of voltage. Like, you can do it with what am I thinking about? Underwater welding in the same way, right? So long as you're meeting the breakdown voltage of water across those electrodes, this should be functional. And I guess if it were going correctly, right, you would almost see a voltage boost between the electrodes when you get fusion, because all of the energy, particle jets, all that kind of thing are going back towards the electrode, so will be captured and maybe boost the voltage. I don't know, like I'm just spitballing here. But basically it kind of solves the need for like, okay, yeah, do fusion reactor, heat some water, use the old steam turbines. It just like we need to move away from steam turbines. Like they're just so complicated. They're so complicated and they rust, so there's more maintenance to do, and that's how you get issues with dams and all this kind of thing, because they're so complex. Like, these need completely retooling. So like that's kind of the philosophy behind this, is like, how do you make something that's like as simple as possible, like something people can 3D print, right? And start like experimenting and doing different things, because like the more people that are trying different things, and like, I mean, like, I'm not the best physicist in the world, like I'm just trying to work out how things work by just messing around with them. Like, I don't know much about the maths, like I do my best to like make sure what I'm doing is evidenced, but I'm a much more physical scientist than a mathematical scientist. And I don't know, I just think we need more of those in the world right now, because there's so much that needs our attention, that more people engaging with physical science in a healthy and constructive way would really benefit everyone right now. And the solutions that you come up with, like as a physical scientist, would be, they could be world changing. If only you would take maybe an hour a day just to like experiment and try something new and like do all that kind of thing. I just think we'd be able to solve these problems in no time, and that's the point of the Fab Labs, right? We need places where you can go to fix and finish these things. Like, I need to go to my hack space right now to do some soldering for all this kind of stuff, and like get everything together to try out a water experiment. But I mean, I don't think that this is good for like high voltage experimentation with like auroras and stuff like that. But I don't think the electronics inside of this small plasma globe are going to be able to meet the breakdown voltage of water. Maybe not writing it off yet, but there's like, the issue is because you're getting very high voltage, you're getting very, very low current, so it needs to be like short loop. But yeah, sorry for the traffic outside. I think that's a pretty substantial update as to where I'm at, what I'm doing, what I've been doing before all the fusion stuff. Yeah, I just hope that a more relaxed format is what people are after. So with that, oh, there we go. So I hope you have a wonderful day. Yeah, just I've got a little Einstein little guy here. He's got like a solar panel on him, and all he does is this all day. I think we would benefit from thinking more.